Okay, so we are back in your binders today with 2012 number 5, which is obviously a nice differential equation. So I'm just going to go through and highlight some key things. The rate at which a baby bird gains weight is proportional to the difference between the adult weight and its current weight. At t equals 0, when the baby is first weighed, it weighs 20 grams. So again, we're going to highlight that as our initial condition. B of t is the weight of the bird, and t is the days after it's first weighed. So I'm going to remind myself of those. B of t represents the weight, and t is measured in days. All right, so and there's that initial condition again. Part A, is the bird gaining weight faster when it weighs 40 grams or 70 grams? And explain your reasoning. So to me, the key calculus word is right here. Is it gaining weight faster? When I see faster, I want to compare our rates. Okay, if you think of you racing your friend, if you said who's faster, you want to know at what rate each person is traveling. So when we see faster, we're thinking rates, which is very convenient because they gave us the rate right here. So I just need to find dB dt when the bird weighs 40. And remember, weight we just circled right here. That's when dB dt when b is equal to 40. And I need dB dt when b is equal to 70. So I'm just going to take that information and substitute it into that formula there. Oops. dB dt is equal to 1/5 times 100 minus 40. So dB dt is equal to 1/5 of 60. dB dt is equal to 12. Now, because dB dt is a rate, and we looked at our units there, that is grams per day. dB dt is equal to 1/5 times 100 minus 70. So dB dt is equal to 1/5 of 30, so that's 6 grams per day. So just make sure you answer the question, is the bird gaining weight faster when it weighs 40 grams or 70 grams? Definitely at 40 grams. All right, part B. So there's kind of a two-step question here. It says find the second derivative in terms of b, period. So let's stop there. Find the second derivative in terms of b. So the in terms of b is reminding me that I can only use the letter b. So let's start with dB dt, which again was 1/5 times 100 minus b. And I need the second derivative, so I'm going to take this and derive both sides with respect to time. So when I derive this side, I get d squared b over dt squared. Now, you can derive this however you want. You can think of it as a product rule. You can think of it as a coefficient. What I like to do is take that 1/5 and just distribute it for myself. So I have 100 over 5 minus 1/5 b. And the reason I do that is it's just easier for me to see. The 100 over 5, its derivative is 0. And the negative 1/5 b becomes negative 1/5. But the derivative of b with respect to time is, of course, dB dt. Now, notice how it said in terms of b. That means you can't leave dB dt here. And of course, it's simple because you know dB dt from the original equation. So I've got d squared b over dt squared is equal to negative 1/5 times 1/5, 100 minus b. So you need all of this for credit for just finding that second derivative in terms of b. And that is pretty much your cleaned up final answer. If you want to distribute the negative 1/5, that's up to you. Now it says use this second derivative you found to explain why this cannot represent this graph. All right, so let's think about what the second derivative tells us, because that's what they're asking us to use. Use the second derivative. The second derivative describes concavity. So I need to know whether this thing is concave up or concave down. So I know this coefficient here is always negative. So I guess the question is similar to a problem we just did. What do you know about this value here? Well, that all depends on what this b value is, correct? So if I look at this function, It looks like B, remember, if you think about what B stood for, B represents the weight. So if I look at this weight, it looks like the weight is traveling between 20 and 100. Now we know it equals 20 because the initial condition was B of 0 equals 20, but I think we can say for certainty that that B value falls between 20 and 100. And I know it hits 20, like I said, because the initial condition B of 0 equals 20. I'm not 100% sure if it hits 100. It looks like it could be asymptotic here. So I'm not going to put the equal sign, but I know it's someplace between the 0 and 20. So now let's just consider that. If I pick a number here for B between 0 and 20, what does that make the value of this? So if I take 1/5 times 100 minus B, if I put in 30, that's 70 times 1/5, which is positive. If I put in 60, 100 minus 60 is 40 times 1/5, which is positive. If I put in 90, 100 minus 90 is 10 times 1/5, which is positive. So it looks like this value is always positive times a negative 1/5, which is negative, tells me if I multiply those, the second derivative will always be negative, which tells me the function should always look concave down. So now it says, explain why this graph cannot represent this because of the second derivative. Well, let's take a look at it. This section here is concave up, and this section here is concave down. And according to our second derivative, and you can write this in your own sentence, according to the second derivative, the function should always be concave down, and clearly it's not in this section. Okay, part C. Again, I think we're pretty good at this. Use separation of variables. Separate the variables to solve the particular solution given that initial condition. So dB dt is equal to 1/5 times 100 minus b. I'm going to cross multiply to bring that dt over. And then I'm going to divide. I'm not going to bring all of it over. I'm going to leave that coefficient, kind of like I did in the problem the other day. I'm just going to divide by the 100 minus b. So as I clean this up, I have dB over 100 minus b equals 1/5 dt. Slap those integrals on, and now this is where we have to be extremely, extremely careful. Don't just jump the gun here. This side's the easy side. I just get my 1/5 t plus c, bam, piece of cake. This side over here, you've got to use the u sub. If u is equal to 100 minus b, du is equal to negative dB. And then I'll have to get that dB by itself, so negative du is equal to dB. So I'm going to keep my integral here. I'm going to replace my dB with my negative du and my 100 minus b with my u. So now when I integrate this, du over u is the ln of u, but it should be negative because of this u sub. And this is why we're not skipping a u sub step, and we're making sure we write that down every time. So I've got negative ln of 100, my u, 100 minus b, equals my 1/5 t plus c. Plug in that initial condition of 0, 20. So here I'm going to get 0 plus c is c. I get the negative ln of 100 minus 20, so I get the negative ln of 80. All right, keep going here. I've got negative ln of 100 minus b equals 1/5 t minus the ln of 80. Now, your gut is probably saying to get to this b value, I need to exponentiate because of that ln. But, there's somebody in the way. You have to first get rid of this negative. So I need to divide everybody by a negative. So now I have the ln of 100 minus b equals negative 1/5 t plus the ln of 80. Now it's fair game to go ahead and exponentiate both sides because the e and the ln are officially touching. So I'm going to carry over here because I've still got a lot more to go. I've got 100 minus b equals e to the negative 1/5 t plus the ln of 80. I'm going to decompose this side. So I have 100 minus b equals e to the negative 1/5 t times e to the ln of 80. That e to the ln of 80 can now zap out. So this becomes 80 times e to the negative 1/5 t equals 100 minus b. And then I'm going to bring the b this way and the 80 stuff this way. So I've got b equals 100 minus 80e to the negative 1/5 t. Lastly, you just want to make sure your condition holds so you know it did it correctly. B of 0 equals 20. Let's just confirm if I plug in a 0, I get 20. So I'm going to go 100 minus 80e to the 0 is 1/5 times 0. E to the 0 is 1. 100 minus 80 is 20, so I know my condition holds. So all in all, I do want to box this answer in for my b of t. This is what we should have gotten. And again, maybe you got to go back and practice getting those e's by itself, dividing by the ln, or maybe it's just the u sub back here. But this is a really great question, and I look forward to hearing your responses.